Okay, so sorry about that. It appears that my Wi-Fi stopped working and it actually screwed up this recording. So I might just actually add two different videos because I still haven't been able to compile two videos and edit it into one. With a free service, they all want to charge me or they want to put a big water logo on the video itself. And I'm like, no, not doing it. All right, so step 3. Take b divided by 2. Your b is a -6 divided by 2 and then square it, which is -3. -3 times -3 is 9. So add the 9, subtract the 9 on both sides. All right, and then what you're going to do is you're going to notice that with this part right here, you created this perfect square. So you can just go ahead and take the middle number divided by 2, which is going to give you a 3, and square it. If you were to go ahead and FOIL that, it will be x minus 3 times x minus 3, which is really just going to give you a x squared minus 6x plus 9. And it works every time because you basically created it. So then what you're going to do is you look at this part here, which is going to give you a 4, okay? And that's your new denominator. Now, as you're comparing this denominator, which one do you think is the closest to either 1, 2, or 3? Well, given the fact that you have no square root, or excuse me, given the fact that you do not have a square root, that's true. Both of these have a square root. You don't have a square root, so I don't think it would apply for 1 or 3. So probably will apply for 2. So let's go ahead and compare that. A squared plus u squared. So then from there, you can see that a is going to be x minus 3. U is going to be a 2. And so once you have this, you can just go ahead and write equals. You know it's going to equal 1 over a, so 1 over x minus 3. Arctangent u, which is a 2, over a, which is x minus, or excuse me, over a, which is x minus 3, plus c. Hold on a second. 1 over a, u over, no, that's correct. Oh, wait a second. Hold on a second. So I actually did this a little bit backwards. Sorry. Let's go ahead and erase that. My bad. And the reason I said that is because remember I said that your u generally is with the letter x and your a is usually the constant? Well, isn't this the same thing as a squared plus u squared, the same thing as u squared plus a squared? So this would have to be a u squared, and that would have to be a squared. So your a is actually going to be 2, u is x minus 3. So 1 over a is 1 over 2. And then u, which is a x minus 3, over a, which is a 2, plus c. So yes, that one is a little bit trickier. So just be careful with that. And I'm also going to write down a little notation here on the PowerPoint, so that way we don't make that mistake in the future. So I'm just going to move it over here. And just hit insert. And let's just put it right over here as a disclaimer, and we'll just say something to the effect of, oh goodness, okay, what is going on? Oh, for crying out loud. Sorry. Okay, we'll just put it over here. Let equals constant. And u equals variable. Okay, so I'm going to go ahead and change this a little bit. we'll have that go ahead and float in. All right. And I'll make sure I want to post this here as well, so that way that gets understood. All right, you guys, let's take a look at example number 5. And I believe this is your last one. So I would recommend that you guys go ahead and pause this one and see if you're able to do this one on your own. So pause the video and give it a try. Okay, so with example 5, you're going to have to do something a little bit more different because the denominator doesn't actually match anything, and neither does the numerator because you have something there in the numerator. So we're going to have to use a u substitution to somehow get rid of that numerator, and then we might have to use a completing the square to change and modify the denominator. So let's start off with the u sub. Remember we said that with the most of the u sub, you want u to be the denominator. So x squared plus 2x plus 2. du is 2x plus 2 dx. So then dx equals du over 2x plus 2. So let's go ahead and rewrite this then. Equals integral 2x minus 5 over u. Change your dx with a du over 2x plus 2. Okay, so at this point, you can tell that, we can't really cancel anything. So, that's not going to help us in this situation. So what if I can rewrite the polynomial on top? So rewrite to the integral of 2x minus or plus 2, because somehow I need to match that. And how can I go ahead and do that? Well, I can go ahead and rewrite the numerator to a 2x plus 2 minus 7. I mean, isn't that the same thing? But I might have to separate them so it's like two different integrals. Okay, over, let's do the x squared plus 2x plus 2 minus 7 integral x squared plus 2x plus 2. I mean, that's still legit, you know what I mean? And nothing's really changed. And then don't forget your dx. So if I do this and I do a u sub, 2x plus 2 over u times, remember your dx right here, you're going to change that dx to this part right here. So that's a du over 2x plus 2. And that's awesome because then this part cancels. So you have an integral of 1 over u du. And you guys remember what integral 1 over u du is? It's ln u, which is going to be x squared plus 2x plus 2 plus c. But that's just the first part, okay, because you still have the second part. Your second part over here, looking at this piece, you want to do a completing the square. So x squared plus 2x plus blank plus 2 minus blank. So your b in this case is going to be a 2. 2 divided by 2 is a 1. 1 squared is 1. So plus the 1 minus the 1. Now remember this piece right here, since you created it, that is automatically going to be, it is automatically be x plus 1 squared, okay? Then your second piece, 2 minus 1, is just going to be 1. Now, which formula matches this? Well, given the fact that there's a plus sign, it's probably going to be number 2 right here. So looking at this, I can see that my A is going to be x plus 1, and my U is going, or sorry, totally screwed that up. U is going to be x plus 1, A is just going to be 1. And you know that the integral of this is 1 over A. So minus, don't forget your 7, 1 over A, which is 1, arc tangent U, x plus 1, over A, which is 1, plus C. Now, if you would like to clean this up a little bit, you should realize that 7 times a 1 over 1 is just a 7, arctangent x plus 1 plus C. And this right here is going to be your answer for this integral. All right, you guys, well, that is basically it for the 5 different examples here. I would like you guys to go ahead and do some extra practices with the 8 cards and the steps that's given to you. So I'm going to have you guys, let's see here. Oh, here we go. So looking at these 8 cards, which are starting right here, you have card 1, 2, 3, 4. Now you have the steps given to you, and I want you guys to do some extra practice with this. So ask yourself when you're analyzing each card, which integral trig inverse formula was used? Was u sub used? What did u equals du dx? Were you able to cancel all the x's value in terms of u prior to the integration? And what was your finalized answer? And I have one other question that I wanted to add here, which is, you probably guessed it, which is, which of the 3 integral equations did you use? Actually, I already have that, just kidding. Formula, which of, yeah, that's correct. And let's see. What strategies were utilized? Random division or completing b squared? Okay. So I think that is about it. There are 8 cards, you guys, so make sure you analyze them. Lastly, I just want to go ahead and show you guys your grades because I did update that on Wednesday. And I try to update it at least once a week. So this is kind of the breakdown of your grades on MS Team. Everything is calculated based on your what you turn in for Math Excel and also your AP College Board or your assessments on Wednesday. So far, I have not inserted anything for your warm-up log because that's due on week 9, or your practicing standards, which is also coming up in week 9. I kind of expect like a surge with your grades because as long as you're showing up to class and you're actually doing the work, everybody generally just get 100 out of 100 because you guys are calculus kids and you're generally responsible. So this is kind of the breakdown. All right, you guys, I hope you have a wonderful week. As always, stay safe and healthy and take care.